Alright, so what we want to do now is solve systems of equations algebraically by the elimination method, often called the addition-subtraction method. Now with this method, what you want is your equations lined up so that the x's, the y's, and the constants are lined up vertically and on the same side of the equal sign. And then what we're going to do is we're going to combine the two equations. Remember, we've already talked about if you take two things that are equal and you add them together, you should get a third thing that is equivalent. So what I'm going to do here is I'm going to add the equations together. And if I take my two x's, x plus x is 2x. If I add the y's, that's going to be 0y. So I have nothing there. And then if I add the constants, I'm going to get 4. And you'll notice that in this case, we get down to something very simple. 2x is 4, so therefore x is 2. And if x is 2, we can substitute x equals 2 back into one of the equations. Doesn't really matter which one, since x and y in both equations are the same. And that will give us the resulting value for y. So 2 plus y is 6, so y is 4. And so my solution set to this system, the point that satisfies both, the point of intersection of both graphs, if you want to think of it that way, is the ordered pair x, comma, y. Alright, here's another example that's a little bit more complex. What was great in that last example I did is that when I added the two equations together vertically, one of my variables canceled out. Now, if I look at this particular question, if I were to add the two equations together, I would get 5x plus 5y is 20. If I were to subtract the two equations, this was the result by adding, if I were to subtract the two equations, because I can do that as well, 2x minus 3x would have been negative x, 7 minus negative 2 would have been positive 9, and 24 minus negative 4 would have been 28. The results that I would have had two variables. And the thing about these two equations, they have the same points of intersection as the original two. So all four of these equations have the same point of intersection. They have the same values of x and y in common. The problem is these equations don't help me, because I'm not able to solve specifically for x and y any further because I'm still stuck with two variables. So what I want to do is I want to be able to add or subtract these two equations together to get an equation that has one variable. So let's go back to a clean slate here, and if we think about it, if we were to add or subtract these two equations together, what would cause one of the variables to disappear would be if these numbers were the same or opposites, or these numbers were the same or opposites. So if I could get a common value here and then add or subtract the equations together, I'll get an equation with one variable that I'll be able to solve. So I'm going to look here with the 2 and the 3. What's common between 2 and 3? The lowest common multiple would be 6. So if I were to take this equation and multiply both sides by 3, that would create a 6 in that position. Okay, so I'm multiplying both sides by 3, as I said. 6x plus 21y is 72. And on this equation, if I multiplied both sides by 2, that would cause a 6 to appear here. So let's multiply both sides of that equation by 2. 6x minus 4y is negative 8. So the two equations over here are the same equations as we started with. They just look different. But the advantage now is that if I go and subtract, I'm going with subtraction because 6 take away 6 will be 0x. 21 minus negative 4 would be 25y. And 72 minus negative 8 would be 80. So therefore 25y will be 80. Divide both sides by 25. 80 over 25. Reduce that fraction to lowest terms, 16/5. So 16/5 is the y coordinate of the point of intersection. Now that I have the y value, I can substitute that y value back into one of the original equations. I'm going to go with equation 2 because the numbers look smaller in equation 2. So I have 3x minus 2 times 16/5 equals -4. So 3x minus 32/5 is -4. I could multiply both sides by 5 just to make the equation easier to deal with. Fraction free. 15x minus 32 is -20. Add 32 to both sides and divide by 15. Reduce that to lowest terms, I get 4/5. So therefore my solution set is the point 4/5 for x, comma 16/5 for y. And so just to summarize this method of solving systems, the adding and subtracting method, what we need to do is, remember, line up the variables vertically, the x's, the y's, and the constants on the same side of the equal sign. And then you want to look for one of the variables to eliminate. And what you need is to achieve the same or opposite coefficients on one of those two variables. So that's going to require multiplying both sides of one or both equations by some number so that one of the variables has like or opposite coefficients. You're then going to combine the equations. You're going to add or subtract the equations depending on what will eliminate the variable you've chosen. You're going to solve for that variable, and then you're going to substitute that variable back into one of the equations to solve the remaining variable, and then state the solution set.